This is the first part of my lectures on PowerTrain. So in this part, I'm going to discuss two topics. One is the general introduction to PowerTrain in hybrid electric vehicles. And second part will give you a brief overview on electrical circuits and electrical power. The first thing is about PowerTrain in hybrid electric vehicles. And if you think about the word hybrid, it means a mixture of several things. So hybrid electric vehicle would involve at least two powertrains in a vehicle. And if one of the powertrains involves electric power, then we have electric vehicles. And so you will need more than just one, sometimes two, sometimes even more, on a hybrid electric vehicle. And as you can see on the diagram here, so we have energy source number one, but that source, whatever that source is, it needs to be converted into the mechanical power that drives the vehicle. Then you have a second source. Again, that could be electrical, it could be mechanical or some other form. Again, that needs to be converted into mechanical power to drive the vehicle. Now, some of the powertrains can be unidirectional. That means power can flow in only one direction. It's like, for example, the diesel engines. Okay, internal combustion engines, they only go one direction, the energy cannot be reversed. But on the other hand, if we think about electrical power can be bidirectional, means you can actually supply energy to the vehicle, but also under some conditions, the energy flow can be reversed, meaning the mechanical power can be converted back into electrical power and then stored in some kind of form, for example, in a battery. Now, the basic demand for any vehicle powertrain is that you need to develop, or the system needs to develop sufficient power to meet the demand of vehicle performance. That means acceleration, overcome all the running resistances, and to deliver the performance that drivers expect. But secondly, you also need to have a vehicle that carries sufficient energy on board, either the fuel, diesel or petrol fuel, or electrical power with batteries storage, or some kind of hydrogen supplies. So you need some kind of storage systems to store sufficient energy on board, so it covers a reasonably good range. And you don't want the car to stop just 5 miles from your home. You want to go somewhere from point A to point B, and that takes energy. Thirdly, it needs to demonstrate a high level of efficiency. That's the whole point of now people use electrical vehicles, or the desired performances. That's to say, a system can be quite efficient. And finally, that's another key issue about the use of electrical vehicles, which is the environmental issues. Okay, you want to minimize the pollutions. So there are several aspects that required of modern vehicle powertrain systems. Now, Unlike conventional internal combustion engine vehicles, hybrid electric vehicles sometimes can be a lot more complex, and they go beyond the scopes of traditional IC-based vehicles. Okay, so typically you would see things like electrical machines, power electronics, batteries, and in addition to conventional ICEs or mechanical hydronic systems, they can also be present in a hybrid vehicle depending on the vehicle configurations. Okay, so it's very highly interdisciplinary because it involves not only the mechanical system, but also you have electrical systems. A lot of different topics that you need to be familiar with. Now, hybrid electrical vehicles comes in several different forms that at different stages of vehicle development. Okay, serious hybrid electric vehicles is one of the early candidates for electric vehicles. Now, this diagram here shows the general subsystems you would expect of a serious hybrid electric vehicle and how they are configured. So on the very left-hand side, you would have an engine that is either a petrol engine or diesel engine. Of course, that comes with the fuel tank. And the engine in a serious hybrid electrical vehicle is not used to drive the car. Okay, it is used to drive something called a generator, okay, which produces electric power. Okay, so the input from the engine to the to the generator is a mechanical motion, but the output of the generator will be electrical power. So that's this diagram, the part that you can see there. The electrical power output is then fed through some kind of device in power electronics called a rectifier. Okay, rectifier typically converts AC power supply into a DC. Now I'll come back to that at a later stage about the AC and the DC and the differences. Okay, it produces the output of the rectifier will be a DC voltage. Now DC voltage and then going through some kind of another power electronic circuit called DC to DC converter, which changes the voltage level from one to another. Okay, and DC to DC voltage converter can be bidirectional. Okay, so you can actually the energy can goes into the DC to DC converter, it comes out and charges the battery, or the battery can go back and provide the energy to the motor to another power electronics that controls the motor. Okay, so the energy can come down, the energy can go up, but the voltage level between the two sides of the DC-DC converter will be different because of the configurations. Okay, so that's battery. Of course, the battery can be charged externally from other sources, power sockets in your garage, things like that. And then this DC voltage, on the other hand, is fed into something called a motor controller, which involves kind of sort of computers, but also something called a power converter as well. That converts the DC voltage into either AC voltage or DC at different levels to drive the electric motor. Typically, we call that traction motor. And the output is then connected to some kind of mechanical transmission, and that in turn drives the wheels. Now you can see here, so the reason why it's called a series hybrid electric vehicle is the engine drives the generator drives the rectifier, the output of the rectifier is fed into a motor controller, and then motor controller drives the motor. And then that motor drives the wheels through some kind of mechanical transmission. So the energy flow is in a series connection. That's why it's called series hybrid vehicles. Now, as you can see from the previous diagram, there are some fairly typical characteristics of a series hybrid electric vehicles. There's no mechanical connection between the engine and wheels, okay, because everything is converted into electrical energy. The wheels are driven by an electromotor. Sometimes we can have separate motors for different wheels. Okay. The engine is used to turn the generator to supply the electrical power. Okay. Of course, you need the fuel tanks, you need the IC engine, that's internal combustion engines, the generators. It consists. These are known as the primary energy supply. So the fuel tank, IC engine, the generator that produces electrical power. Batteries function as the energy bumper. It's actually storage. Okay, it makes up the difference between what's required by the electrical motor or the traction motor, and sometimes if the engine doesn't provide you enough energy. Okay, so if your motor asks for more than what the engine produces, then that's where the battery comes in. And of course, you need a lot of power electronics there that converts from AC to DC, or different level of DC to another level of DC, or DC to AC. So there's a lot of power electronics involved. Okay. Now, series hybrid electric vehicles can work in a number of different modes. Now, over here on this slide, and I produced, well, actually I found a different diagram, which is really the block diagram of the overall configuration that I showed you in the previous slide. Okay, so hopefully this really sort of give you a better view or better impression of how the systems are connected. So you have the engine here, the generator, and then rectifier. This is where the DC link is, and DC link charges battery, connects to the battery, but also connects to the power electronics that controls the motor. The motor drives the mechanical transmission, which in turn drives the two wheels. So the first mode of a hybrid electric vehicle is called pure electric traction mode. Now, in this mode, the engine doesn't work. The engine is switched off. Okay, so there's no energy flow from the engine. The only energies come from battery. Okay, if there's enough battery power, the battery supplies the inverter drives the motor drives the electrical transmission. Okay, so that's the first mode of a series hybrid electric vehicle. But also, there's another mode where the energy to drive the car or a vehicle is purely coming from the engine. Okay, so engine, in this case, the battery does not do anything. Okay, it's not taking energy to store the energy. It's not outputting energy either. So the engine drives the generator. Generator produces a voltage that drives the inverter. Inverter converts that voltage into the form that electromotor needs, and that drives the mechanical transmission. Now, everything, what I've not done here is all the control systems involved, because to produce the voltage for an output of the rectifier, and also from the voltage through the inverter to produce the voltage that motor wants. Okay, there's a lot of complex control systems involved. Okay, so there's, nowadays typically they are produced in the form of computer software. So they're all controlled by a computer or several computers. Okay, but that's other topic for discussions later on. But that's the second mode. Okay, so the pure engine traction mode. The third mode is called hybrid traction mode. Now, in this case, the battery has already stored some energy. So also the engine is producing energy as well. Now, the motor is probably trying something very hard. So, for example, driving at high speed there's a lot of running resistances, or is accelerating fast. So it demands a lot of power. In this case, the engine itself is not sufficient. Okay, so you need both engine and battery to provide provide the motor with the high level power that's needed to drive the car. That's typically when the car is working very, very hard. Okay, and the energy sources come from both of them. But again, they are converted. The energy from the engine is converted into electrical power first. And the battery, of course, stores the electrical power. That's third mode. The fourth mode is when the vehicle is cruising. When the vehicle is cruising, it doesn't ask for a lot of power or doesn't need a lot of power. Okay, just keep the vehicle going. It needs a little bit of power to overcome the running resistances, but the engine has a surplus. Okay, now engine have surplus, therefore at the same time engine can be used to charge the battery. Okay, so you have battery in charge modes. You have both in traction, but also in the charge mode for the battery. Now, the reason why engine sometimes charges, sometimes drives the wheels, sometimes it doesn't, is because engine is at its best or the most efficient condition when it's running at a certain speed and in certain defined power range. So that's the engine. We try to run the engine at a fairly constant condition. Okay, so but the demand to drive the car or drive the vehicle can be different depending on the circumstances. So in this case, the engine produces enough power to keep the vehicle going, but also is able to charge the battery as well. The fourth mode is when you are braking. Now in this case, we don't need the engine anymore. We can actually switch off the engine. The engine is not doing anything, and therefore it's not wasting fuel. And the mechanical power in this case can be fed back through the motor and to charge the battery. The motor in this case works as a generator. So it converts energy back, this mechanical power back into electrical power through the inverter and charges battery. Okay, that's one of the other reasons why electrical vehicles or hybrid electrical vehicles are more efficient. Now, in a conventional vehicle, when you brake, you use brake disc and brake pedals, and the braking force is provided by the friction between the brake disc and the brake pads. Now, the energy is wasted. But for an electrical vehicle, we can actually convert that energy, or at least a part of that energy, back into electrical form and charge the battery. And then the energy gets stored there. Okay, so it kind of helps to improve the efficiency of the overall system. And of course, there will be conditions, for example, when you're cruising or your car's stopped, and it doesn't need any power to drive the wheels, but the computer or your control system might decided that the battery, the energy in the battery is quite low. Therefore, it needs charging up. So it doesn't stop the engine, but it uses the engine to generate the electrical power to charge the battery. So in this case, it's purely from the engine to the generator, amplifier, and then that charges the battery. So that's another working mode. Okay. And finally, if the battery is really, really low and you are under braking, but you can actually produce energy from the braking to charge the battery, but at the same time, you can actually keep the engine running as well. Engine will help to charge the battery. Okay, so that will be the final working mode. So there are really 7 different kind of modes for serious hybrid electrical vehicles. Just to summarize the advantages and disadvantages of serious hybrid vehicles. The advantages include things like because there is no mechanical connection between the engine and the driven wheels, therefore you can optimize the engine operation as simplify the control of drivetrain. So your engine is kept at really the best working condition. The issue I mentioned early on. The second advantage is in the transmissions. Electrical motors tend to have a better torque speed profile that is typically what we need for driving. So at lower speed, the electrical motors can produce a high torque, and at high speed, it can be kept at a constant power region, but the torque can be reduced. But if you think about driving, we tend to have a high demand for torque because we are accelerating at a high speed. Once this vehicle speed is up and running, and you don't need to accelerate anymore, all you need is actually try to overcome the running resistances. In these cases, in this condition, the demand for the power is less, or the torque is less. Because you don't need to accelerate. Whereas internal combustion engines don't have this kind of characteristics. That's why we need clutches and multiple gears to try to get the engine to work in a sort of close to a good performance, but never be ideal. The third advantage is that it is possible to use more than a single motor. Now, a lot of hybrid electric vehicles nowadays use a single motor. They replace the engine driving the wheels. But it is possible to have 2 wheels for the front wheels, 2 motors for the 2 front wheels, or 4 motors for all four wheels. This will give you extra flexibility in how the motion and how the steering can be controlled. Okay, the smaller, obviously, if you want to use more than one motor, the size of the motor can be smaller as well. Sometimes you can actually attach them to the wheels. Now, disadvantages include energy losses, because now you convert, if you think about how the energy flows in the system, energy produced from engine is fed to a generator going through a rectifier, that goes through a DC voltage, then goes through an inverter, and then to the motor. It converts the chemical to mechanical. Chemical, that's the fuel, burning the fuel. To mechanical, that's the movement of, or the rotation of the engine. That drives the generator. So mechanical, the output of generator gives you electrical. The electrical going through various converters to the motor. Motor converts the electrical back to the mechanical. So every stage of that conversion produces losses. Okay, therefore, sometimes the overall efficiency of a series hybrid electric vehicle can be quite low because all the losses, because all in the conversion process. And also because the vehicles are driven by electric motors, not engines. The motors and generators, they need to be powerful enough, therefore they need to be fairly large in size and also in power. That creates, of course, results in extra weight and high prices. The electrical vehicles or hybrid vehicles are not cheap, as we know, in comparison to conventional ICE type of vehicles. Okay, and I'll give you a break, and then we'll continue the discussions in a minute. Thank you.